you know, the little video from his presentation, and he had, you know, a whole lot of buildings lined up. I don't know if I've got that building page any more of them left. Oh, let's have a look at this one. So he had it all lined up, and he goes, okay, well, so here you have a 3-story pole, and here you have a 4-story pole, and here you have a 2-story, 2-story, 3-story, 2-story, and that's exactly his pitch, right? We sell you one range of poles, and then that in your truck you'll have, you know, one pole for each story, and that's how I used to sell. I don't begrudge that. I just think that it's archaic, you know, with the knowledge that we have. But here's this: if you had a 1-story pole plus a 2-story pole plus a 3-story pole plus a 4-story pole plus a 5-story pole plus a 6-story pole. Let's say we stop at 6, right? 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21. You end up with enough carbon fiber to clean 21 stories high in order to clean 6 stories, right? And you have a look at Reach It. We say, okay, you have enough, let's say, you know, it's a Warrior, so you have a 4-story pole, and then you go plus 1 equals 6. That is what started Reach It. That's what made me manufacture, right? Because I realized the internal tube, the glued on clamps, everything was designed to say, you know, and I used to sell, like I started selling like this, so it just, you know, I've been there, is fixed length poles are designed to persuade people to buy, you know, the longest pole they can, and then it becomes heavy. They know it's going to become too heavy to clean below, so they go, God damn, this is so hard, right? Excuse my cussing there. Then, you know, this is so getting heavier and harder. Oh yeah, you need a 3-story pole. Oh yeah, you need a 2-story pole. They don't sell the 1-story pole and they say, oh, you need a longer one. They sell the heaviest and longest pole first and then pull it down. So there are more guys in the market, like with pull apart as a function, which we'll cover pull apart in a minute. So that's good to see everybody following with pull apart. We were the leaders of the pull apart philosophy as well. Okay, so what else can we talk about? Well, let's go to, you know, after the poles, we want to talk about brushes, because it's actually the brush that cleans the glass. So the sad thing is, like when I go back to when I started in 2006, we basically bought a pole and it had a brush on it. You know, in our day, it was a VCAN truck cleaning brush. And we never, for 3 years, we never took that brush off. I mean, that was my water-fed pole. So that when you hear people talk about water-fed poles, it comes from, you know, 50 years ago, whether it's from a tucker or from the other people that joined the industry afterwards. You always bought a pole and a brush and you never changed the brush. So the problem with that is trying to make a universal brush that's efficient is really, really difficult. And the reason why the efficiency is lost is because you have all these different kinds of windows. Right, so residentially we have the cut-ups with small cut-ups, maybe 6 inches. Then we have the French panes, you know, usually divided into 4. We have double hungs, we have side-by-sides like this. Downstairs we've got ranch sliders or great big, you know, open windows and big area windows. So the logic, right, is to say, oh yeah, I just want one brush that cleans all. It doesn't make any sense because you wouldn't use one squeegee to clean all, right? So if you just apply your squeegee philosophy to your water-fed brush selection strategy, you can see this wide channel and you can see this, you know, like standard, you know, brass channels or whatever. So you can see there's different technologies, and then there's the Mormons and the wagtails, like for swivel heads and stuff like that. So you can see the water-fed industry has got, you know, a similar range of options as people are pursuing, you know, efficiency, and other people are sort of staying with what's always been. So, you know, here you need a particular kind of brush, right? It needs to be a dual trim, right? Because you need to be able to ride over those frames and clean the frames as the brush goes over the frames. It shouldn't be too big as a brush. This one needs to be a small brush, so it's probably going to be a 12-inch. Again, it's going to be a dual trim, you know, which is what we call all-rounder, right? Because you need, you know, basically a dual trim. You know, if this is the block of the brush, it's got a trim here, and then it's got 1 or 2 rows of bristles here that are longer. And so in this sense, these bristles can stay on the glass while these bristles clean up over the frames. Otherwise, if you had a single trim and the brush was all this length, then when you hit the frames, the whole brush is coming off the glass, so you can't work it. So there's definitely a dual trim thing there. And then these, the double hungs, as a rule, because it's not the size of the glass that slows you down, it's the frame. And so these are actually like quite laborious, getting into the corners and around, and they're deep set, so it's not as much fun. The bristles don't ride over the frames like in an aluminum, low profile frame environment. And then you've got the side-by-sides, which are great big pieces of glass. Downstairs you might have huge pieces of glass. So, and then that's just on brush size. So in reality, you want something like a 12-inch brush. Now just watch this one. In the marketplace, what we know is that, basically you have a block, right? And then you have bristles. When you compress that brush against the glass, the bristles splay out, yeah? And so one company will tell you, let's say these are both got a 12-inch block. One company will tell you it's a 12-inch brush, right? That's what we do. Another company might tell you it's a 16-inch brush because the bristles are splaying. Again, it's that logic. Is it a 12 or is it a 16? Because when you press it against the glass, it's got the ability to agitate a 16-inch stroke, or is it a 12? It doesn't matter as long as you know what your thing is. Both of them are going to agitate 16 inches, around about 16 inches in a single stroke, right? But we call it a 12-inch brush because the block is 12 inches, right? And then you want, a 16-inch block or a bigger brush, and its job is to clean the big panes of glass. Now you'll see that we're bringing out Reload now, which is like a gunslinger for waterfed, so that you can carry a 12 and a 16 on your hip if you're using reach it gear, right? So if you get this 12 and the 16, then you're going to be sweet. You can just switch them out. Otherwise, going back to the car to change your brush, you know what's going to happen. You're not going to do it. But there's efficiency in using bigger brushes on bigger area, just like there is when you carry, like we look at the people, what they carry in a gunslinger, they're always carrying, different size channels so that they can be efficient on different size pieces of glass. The math's the same, physics is the same. Okay, just be aware of this, that when you've got a 12-inch square, right, and then you've got a 16-inch length, right? The pounds per square inch, if you applied the same amount of force against the glass with this brush as you do with this brush, you will have more agitation power from the smaller area than you will from the bigger area. So if you're doing regular cleaning, just stuff that's landed on glass, whatever, then you'd be using 16 and you can cover, or even like we've got 20, and like somebody might have seen my post the other day where we made a 36-inch brush and somebody said that won't work. The 36-inch brush will work because they're cleaning every 3 months, right? They're only taking stuff off the glass. Yeah, so this is all part of that. What you need to know, I think what you need to know is understand, okay, you want 12-inch and 16-inch. 16-inch covers more glass in a single stroke. However, 16-inch has less pounds per square inch force from the same amount of effort from the worker. So therefore, if you have a high amount of, concretions, excretions, or, difficult to remove stuff, then you're going to go to a smaller brush and make more strokes, to get it off. But it'll still be less strokes than you would be if you were using 16. And then, of course, the ultimate solution to that, what we brought out just recently, is Window Weapon, which is focused on non-water soluble concretions, excretions, and pollutions, right? Window Weapon is focused on that because if it doesn't dissolve in water, it doesn't work with waterfed. Yep, in the history of waterfed. All right, what else have I got on my list? Oh, let's cover brush size commercial while I'm talking brush size, right? So the same happens to the dude, right? When he's down, you got the dude down here, or the lady, and he's got his pole, up here, and then the commercial building, to make it look pretty, will have big windows, and then they'll have a row of small windows, and a row of small windows, this is actually the concrete, just covering the concrete, let's say, between the floors. And so, and then it can get worse than that. They might want to make this building look, really pretty, and make it so that they're like this, and this can make the building really pretty, but you have more frames. It's not the size of the glass that slows you down, it's the frames that slow you down. So you can imagine that this building has just become, way more pretty, but the problem for the window cleaner is he's now got a whole lot more windows to clean, right? So he's got to get in there and he's got to work out which brush can fit in there, and then all of a sudden you can't even get your big brush in here and maneuver it around and get into the corners and all that. So same as you would with a squeegee, if you were nose to glass, you'd put a 12-inch in there and get these two rows done with 12-inch, and these ones done with 16-inch. Yeah, like that. So that's why you want to carry 2 different size brushes. And you can go to, if you've got glass-clad buildings, then you'd go to 20-inch or 24-inch, subject to your ability to deliver, water pressure to the pump. Yeah. All right, let's talk about, so you want to, how to buy a water-fed pole from a designer's perspective. Well, there's basically, let's talk about pole sections and pole construction. Firstly, like the concept of lightweight, right? So there is a brand which makes a lightweight pole. Now, there is no such thing as lighter carbon fiber. You can't go to the market and buy, I want super light carbon fiber, all right? Well, that's Australian, okay? There's no such thing. It doesn't exist. The only way to make a pole lighter is to use less carbon fiber, right? So if a reach it, we have, basically it's a composite with a laminate plan, right? And so we have 8 to 9 layers of carbon fiber. The strands are about the size of a human hair, and we align as many of them up the pole as we can. Yeah. So basically, it looks like that. But of course, we have 3K. The thing about 3K, there's no pole made of 3K. If somebody made a pole out of 3K, it would be floppy, right? 3K is a grid, right? 50% of the MSI, right? MSI is your basically measure of rigidity. Right, so 50% of the MSI is going up the pole, and 50% of the MSI is going around the pole. So you want to minimize the use of omnidirectional, multiple directional woven products. You want to minimize the use of that in pole design. So we just put a layer of it around the surface, because when we make one like this, there's a risk that it'll delaminate because the fibers are all like this. So we put a woven this always looks beautiful, right? It could be 3K, 6K, 12K, whatever, 90 degrees, 45 degrees, different angles, different sizes, different thicknesses of the strands and all that sort of stuff, but it's all the same stuff. It's just there to hold the pole together at the end, and also to, we need whatever, I'm not going to tell you a whole lot about it, but we need other what's called hoop strength, other layers going this way, otherwise the pole would just crack. But if you had all of the layers going this way, the pole will crack immediately, right? You squeeze it and it cracks. So how do you make a pole lighter? Well, if we've got 8 to 9, then if you put 5 layers, you'll have 5/8 is, I don't know, it'll be 60% lighter, yeah. But it's still got to have omnidirectional, and it's still got to have unidirectional, so it becomes more fragile, more likely to break, right? So and then don't be fooled by somebody saying that it's Kevlar if half of the strands going one way in a 3K are gold and the other half are the other way, black. The black ones are carbon fiber. The carbon fiber will conduct electricity. The fact that there's Kevlar in there won't protect you at all, just as a side note, right? So the other thing is that you'll see that we do, and I'm really pleased to see more companies doing it now, is that you can see a rough surface on the pole is going to wear down, and a smooth surface will not wear down, basically, in comparison, depending on the clamps. If you make aluminum clamps, then the aluminum clamps will last a lifetime, because the part that's going to wear down is your carbon fiber tube. If you make nylon clamps or plastic clamps, then in theory, the softer material will fail. There's always a sacrificial part when you've got 2 moving parts, repetitively moving against each other. So everybody should be making the clamps bolt on and replaceable, not the tubes being worn down. But the second thing is that if you have a corrugated surface, so there's basically 3 designs. There's one which has actually got a corrugation. It's kind of the sine curve is bigger. The other style is where the resin from the manufacturing process is just left on, like nobody takes it off. It's great if you can do that because it's cheap. But like what we do is sand all that off and get a standard smooth surface. And then when we clamp to that surface, it's not going to wear down. Whereas when you clamp to a corrugated surface, then the corrugation's going to wear down, and it doesn't matter if you replace the clamp or not. You can't replace a clamp, and if the OD, the outside diameter of that tube, is broken down, right? So you can't clamp to something that's smaller. So these wear down, and then you have to buy a whole new pole. These wear down, and then if somebody can persuade you to run the tube inside the pole, that's like gold, right? Because now you're going to have a clamp, which I just don't believe in. So you have a clamp running on a corrugated surface with dirt and grit being brought up from the ground. The dirt and grit gets into the relationship between the clamp and the pole, and then that wears down whichever one's more sacrificial, right? Probably both, because corrugations, if a piece of grit gets caught in here, it gets worked in the corrugation and wears more off these. If you can just get rid of the high points, then the clamp won't bite on it. And there's some other things on that coming out with some of the guys have got shims and things like that. So it's just design points. But if you can get this one to wear down, then the same thing. Like if you can get sand and dirt and grit in there. So, from our design point of view, we have a smooth surface. You want a smooth surface pole so you can't hear it like that. You want to know that it's unidirectional. It's got unidirectional. It's really rigid as anything. The weight of the pole, like our answer to weight, we don't make a lightweight pole. My answer was simply, firstly, let's get rid of guys, holding the brush off the glass and squirting water at the glass. So on glass rinse was, with the constructor brush was my target, so that the guy's always got the pole leaning against the glass, and then make that pole pull apart one story at a time. So, if it's 6 pounds here, it's 4 pounds here, it's 3 pounds here, it's 2 pounds here, it's 1 pound here. It gets lighter as he finishes, as he cleans from the top down, right? That's the other answer to lightweight. The other way to make a lightweight pole, by the way, is to make it out of very long, thin sections, right? Because you use less carbon fiber in a thin section than you do in a thick section. So if you make very long, thin sections, you can make that pole lighter. The problem is that when you go to put somebody's hand on that, right, his grip on that pole is going to be on something that's not ideal for him, and he'll end up with cramping hands and possibly a carpal tunnel injury. So there's don't use thin poles all day every day, I don't think. Alrighty, how are we going? Woohoo! Cranking through this. Poles do not clean glass, brushes do, we've done that. Oh, let's talk about floppy versus rigid. Alright, this is really critical. So the rigidity of the pole, if you've got a guy here, right, and the rigidity of the pole is really critical to him. So let's say we have, a directly straight line, and then you've got the brush on the glass. So he's basically moving in this direction, right? Obviously his arms are moving up and down a little bit, yeah? But this here is actually his drive shaft, yeah? That's what he's doing. He's doing the work with the biceps, triceps, pecs, lats, legs, all of that. He's doing all that work, and he's asking the brush to go up and down like this on the glass. Yeah. Now, if he's got a swivel there, like side to side on constructor brush, then it's also his axle. Yeah. So now, if you compare that, as soon as you get that, right, there goes your building, there goes your guy. Hoo-hoo. And now you give him that pole. Now, when he does his effort in this direction, that is, instead of it, transferring it in a linear sense, like X, Y, right? It's a straight transfer of that energy like this. Now he's losing that in the flex, yeah? So that's his effort being lost in flex. And then eventually the pulse, he puts a pulse in the pole and the pulse goes up, and then the brush goes up. Then he has to bring the pole down, and the pole comes down, and then he wants to push the pole up. So he's going to, keep flexing. So every time he does that, he loses energy here, right? He just loses energy in the thing, and then he can't control it, and then it whips, and then it's just endless. So what's the answer to flexibility or rigidity, right? In my opinion, the answer is called video, right? That when you go to buy a water-fed pole, you should be able to see the pole in action at its different extended lengths, whether it's its maximum extended length that it's being sold for, and or recommended for, because obviously, you know, carbon fiber pole can go even higher again. But you know, that's what we do. Is like, you know, we have Warrior at 65 feet videos. You know, we can pick a 50-foot pole up from the ground, you know, and show that it doesn't flex very much when it's just a straight pickup. Yeah, so it just fascinates me that there's nobody else out there who's got videos of their products in use, being used at the fully extended. So you get a 640 by 640 pixel with a picture of a pole and a brush, and then a little tag in the e-commerce store, you know, $11.95 or something, right? And then obviously a salesman is going to tell you the rest. Yeah, it's the same as Reach It, or it does this or it does that, but, you know, can you send me a video, please? Right, would be a really clever thing to do. And just say, because we see this, like, you know, we get people returning products and buying Reach It, even when they've, especially, it's much easier if you've actually already owned a Reach It, and then you have a look at the other brands, and then you end up being able to compare. So that happens. But, you know, how do I initiate that? Well, if it's a new pole, then I just send them a video and say, well, this is when your pole arrives, put it up against the building and compare it to this. And then, you know, if it doesn't match, then you know. It's really easy, right? You can return it and then buy our pole, because at least we can show you what it's going to look like. Yeah. Okay. So that's rigidity. I do want to cover this one. Length. I shouldn't have done any of these this thing, but it's basically length versus reach. So somebody wants to sell you a 30, let's say a 35-foot pole. Yeah. What does that mean? Well, you could, let's say this 35-foot pole is this length here, yeah, just so we can match it. If we manufacture the pole and it's compact, right, height is whatever, you know, so you have a compact because it's telescopic, and then a fully extended length like this, yeah. So somebody says it's 35 feet. Well, the question is it 35 feet of pole? Or have you, you know, added the operator, because this is what happens, is what we call 35-foot reach, because you don't operate the pole from the ground, right? So then what they do is they then tell you this is a 35-foot pole to here. So you know, the way I talk about it is I'll say out of the box, you know, let's say I know tactical with shock stop is 30 feet of pole, right? But it has a 35-foot reach. Yeah. So you've got to know the difference between a 35-foot pole, actual length, and a 35-foot reach. And there are a lot of products out there that have 35-foot printed on them, right? When it's this style of, where it's actually a 35-foot reach. But I say, well, hang on, dude, like, you've already paid the money for that. Yeah. Like, you've fed that, grown that, right? So that belongs to you. I'm not going to sell you back, but I will tell you that you don't operate the pole from the ground. So you can add another 5 feet, 6 feet, whatever you want to do, you know, as far as how high you can reach. I mean, I've got guys who, you know, basically, you know, can clean windows with their arms like this, and, you know, they can add 8 feet to it. Yeah. So then they're going to be way up here. Yeah. Off the page, off the chart. So watch out for this one. Yeah. Is it 35-foot length, or is it 35-foot reach? Right. Okay. Good. Getting there. Boom. Pole selection guide. We've done that. Then the other thing is, like, what else is? I wanted to talk about extendability. Yeah. And pull apart. Actually, I haven't done pull apart. Okay, so there's two kinds of poles. There's basically fixed length poles in the market, and there's pull apart. Yeah. Now, some pull aparts are really lazy. It's just it's just a tube section that'll pull out of the pole. Hey, that's the cheapest way to make a pole section, right? It's just to have it. You don't add anything to it to make it not pull apart. It's just a tube comes straight out of the machine like that. So Hey Paul, good to see you. So if you get fixed length, then you're going to end up with, you know, a pole for this, a pole for that, a pole for this, a pole for that, and a pole for this, right? So all these different fixed length. Whereas if you get pull apart, then you basically have a master pole that can be extended, yep, and these extensions are actually in the middle, but for the point of the drawing, and then you would then take off 2 sections, lay that here, and then you would, you know, if I do it with blue, maybe this one, right? And then you take off 2 sections, and then now you've got like this, a shorter pole, and then you take off 2 sections, right? So now it's like this, and now you've got a shorter pole, and then you take off 2 sections, right? And then you come down. Now, in theory, you'd be on your extensions, right? So you'd have 1, 2, 3, and then 1, 2, and then 1, and this would be your extensions laying on the ground as you clean from, because all cleaning is from the top down, right? Apart from some soft washing. Yep. So that's why you want pull apart. So somebody says, how heavy is a warrior? Well, it might be, I don't know, it might be 6 kilos here, 7 kilos there, 4 kilos here, because the heaviest part comes off is that handle, right? And then 3 kilos, 2 kilos, 1 kilo. What's that in pounds? This might be, I don't know, 12 pounds, 8 pounds, 6 pounds, 4 pounds, 2 pounds, half a pound, you know, like that. You know, depends whether you include the brush or not. And then if it includes the brush, it depends how big the brush is. So this is just variables everywhere. So, you know, to make the pole lighter, you know, it gets lighter by taking it apart as you come down. And from a functionality point of view, it's also more rigid, it's more nimble, you've got more precision, more accuracy. You're not lugging a great big heavy pole around in your logic on that. So if that's, let's see what this is. This is pull apart. Yep. And then Judd is here. Dude, I am cranking away at how to buy a water-fed pole from a designer's perspective. Okay, so now we have